everyone, so this is going to be your section 1.2 notes. The first topic that we have is a Venn diagram. And you guys may be used to this actually in like the English or reading context or like compare and contrast. But it is a graph that helps compare and contrast sets. Each set is represented by a circle, and circles that have elements in common overlap. The circles are usually enclosed in a box, which represents a larger set and provides a space for elements that do not belong within any circle. So in our first example, we're going to use a Venn diagram with circles representing prime numbers and even numbers to sort the whole numbers 1 through 10. So the first thing I'm going to do is I'm going to draw a circle, one that will represent our prime numbers. And then I'm going to draw another circle that will represent our even numbers. I will enclose both of those circles within a rectangle. I am now going to figure out which numbers are going to belong where. So we have the numbers 1 through 10. One thing that I would want us to do is figure out which ones are even, and then also figure out which ones are prime. And I'll actually switch where I'm writing each of those. So we've got our prime numbers and we have our even numbers. And there might be some that end up being in both lists. So even numbers 1 through 10, 1 would not be even, but 2, 4, 6, 8, 10, all of those are even numbers. Prime numbers, you may be wondering again what the definition of prime numbers is, and it is any number that is only divisible by 1 in itself. So for instance, 1 is prime because only itself and 1 can go into 1. 2 is also prime because only 1 times 2 will give you 2. 3 is prime. 4 is not prime because you have 2 times 2. 5 is prime. 6 is not prime because you have 2 times 3. 7 is prime. 8 is not prime because you have 2 times 4. Same with 9, 3 times 3. And 10 is 2 times 5. So these are our prime numbers. So when I look at where each of these numbers will belong, I want to look at any numbers that end up in both. So if I look at the number 2 is in both prime and even. So 2 will go in the middle there. 1 is just in prime. 3 is in prime. 5 is in prime. And 7 is in prime. We also want to look at which ones are only even. So 4 would be even, 6 would be even, 8 would be even, and 10 would be even. One thing that we would want to just consider though is if any numbers fall, I did not forget a number. There was a number that we did not count because when we look at it, we've got 1, 2, 3, 4, 5, 6, 7, 8. We are not missing, we do not have 9. 9 was not included. 9 is not prime and it's not even. So 9 will go on the outside. So the outside of the circles, but still within the rectangle, that represents anything that's not prime or not even. So it's always a good idea to kind of remember that when we think of our circle, it covers this entire space that's in the green for even. And when we think of our circle for prime, it covers this entire space that's in the pink. And so when we look at our 2, it's in both sections. It's in the overlap. And when we look at our 9, it's outside of both. Okay, example 1. Some of these are just some application questions and just getting us started on some word problems. This one says, in a class of 20 students, 17 of the students passed a prerequisite skills. What percent of the students passed the quiz? So when we have this, to find the percent that passed, we're going to take the amount that passed, or like the wanted out of the overall total. And we're just going to divide. So that will help us figure out what it is as a percent. So we get 0.85. Then to change it to a percent, because right now it's as a decimal, to change it from a decimal to a percent, we're going to multiply by 100. So we get 85%. For example 2, it says at a particular college, half of all freshmen start in developmental math. Of those who start at this level, 4/5 start in beginning algebra. What is the chance a freshman at this college starts with beginning algebra? So for this one, we want half of all freshmen, and of those, we want 4/5. So we want half of 4/5. And of means to multiply. So we are just going to multiply the two fractions. So we're going to take 1/2 and multiply it with 4/5. When we multiply those together, we end up with 2/5. For operations with fractions, you always will check to see if a fraction can be simplified before you write the final answer. For equivalent fractions, an equivalent fraction can be written with a different denominator by multiplying or dividing the numerator of the fraction by the same non-zero number. So for instance, you can either multiply the top and the bottom by the same number, or you can divide the top and the bottom by the same number. So for instance, if we want to make 2/3 into an equivalent fraction, I can't really divide anything for each of those, but I could multiply by, let's say, 10. So I would get 20/30. If I wanted to, I could just also take 2/3. Maybe I want to multiply it by 7. So I would get 14/21. All of those, 2/3, 20/30, and 14/21, all of those are equivalent fractions. Say that I want to do the same thing, but maybe I want to make an equivalent fraction by dividing. So in this one, I could find something that's divisible into 24 and 36. So for instance, 6. Both of them are divisible by 6. And we would get 4/6. So that would be an equivalent fraction. I could even take that then and divide by 2. And I could get 2/3. So all of those three, 24/36, 4/6, 2/3, all of those are also equivalent fractions. The last topic that we have for section 1.2 is to convert a fraction to a decimal. So to change a fraction to a decimal, you'll first write it with the denominator, that is a power of 10, or use your calculator to divide the numerator by the denominator. I think it is easier to always do the second one. So sometimes they also don't end up perfectly to get a denominator of that's a power of 10. So I think it's easier to just in general divide. So you're just going to take 2 divided by 25. And so we get 0.08. Just as simple as that. For this one, we're just going to take 6 divided by 7. This one ends up being a long fraction, so let's just go ahead and just list 4 decimal places. So we get 0.8571. Okay, that sums up section 1.2. If you have any questions, please reach out.